Here we go. So on top of your paper, can we please label it 9.1 day 2? This is now day 2 notes on a lined sheet of paper. 9.1 day 2. So all of us are writing this down, okay? It's not a matter of you sitting there and just looking, because I feel like we really need to practice it and try it. So let's all write this down. By the way, while you're getting yourself set up, I wanted to give you a reminder that your 9th grade course selections, they're due this Friday, okay? So please make sure that you have them entered. Are you guys entering them into Skyward? Is that, okay, so into Skyward, make sure you have your 9th grade courses selected. I think you can change them like maybe later on, next year, if you decide last minute in the fall that you want to change your schedule before school starts, but they need something to go off of, okay? They need some sort of schedule for you. So they can't build a schedule for you, and I don't want you to get really, really bad random classes because you didn't enter anything in there. Garrett, did you have a question?
Oh, you answered it.
Oh, okay. But I think if you do want to have it changed, like in August before school starts, you're probably going to have to call the counseling office, blah, 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 blah. So try to keep it like as close to what you want to do now. And then if you have to change it, then yeah, obviously you have to call the counseling office. All right, here we go. So let's try a couple, okay? Let's do a couple of what we did yesterday, and then we'll move on from that. So let's start with something like this. 3 square root 12 plus the square root of 108. So that's my problem. 3 square root 12 plus the square root of 108. Or I can call it 3 radical 12 plus radical 108. So square root and radical is basically the same way to say it. So remember how we said when we're adding and subtracting, I can't combine these things because they have different endings. One is a radical 12 and one is a radical 108. But what I can do is not say, oh, can't solve it. What I can do is simplify each one, because I can break down 12 and I can break down 108. And from there, maybe I can combine them then. Okay, so let's break down 12 first. 12 is what times what? 4 times 3. If you said if you said 6 times 2, that's okay. You can write down 6 times 2. You're just going to be breaking it down different than us, but that's okay. You'll still come out with the same answer. Okay, I'm circling the 3. Remember, I only circle the prime numbers. 3 cannot be broken down anymore, so I circle the 3, but don't circle the 4, because 4 is 2 times 2. So now I can circle the 2's because I can't break down 2's anymore. Okay, so if I have the square root of 12, remember how I said, okay, there's an imaginary 2 there. So what that means is I'm going to take out groups of 2 of the same number. So I have 2, 2, so 1, 2, cross out both of them, and then write it out once on the outside. I have a 3 here that does not have a friend because there's no other 3 to break off from. So I have to leave it on the inside. Yes, Emily? Yeah. And then, so this 3 right here, remember it was originally on the outside. You just drag it down. So you don't forget that there was originally a 3 on the outside. Okay, so this is me simplifying that. That actually becomes 6 radical 3. So remember, I can't do this stuff in the calculator. I can't just type the problem in the calculator and get the answer, because that would give me a decimal. It doesn't simplify with radicals. My calculator does not. Okay, 108, I can simplify that. So 108, what goes into 108? 8. Okay, I heard a lot of numbers. So definitely 2. So if you absolutely don't know, then definitely 2, because it's even. I heard a 12, so I'm just going to say 12. Oh, 12 and 9. But if you want to do like 2 times 54, sure, you're just going to get different little brackets than us, but you're still going to get the same numbers. So I heard someone say 12, so I'm just going to say 12 times 9. I'm not going to circle 12 and 9 because those can be broken up even more, right? So 12 is 6 times 2, 3 times 4. Yep, same thing. You're still going to get the same answers. Yes?
I'm confused on why you multiply the 3 times 2.
Okay, so do you see how square root of 12 here is just 2 radical 3?
Yeah.
But then do you see how my original problem had a number on the outside? So that doesn't just disappear. It just like put it here, continue to put it on the outside. So if you had a 3 on the outside, but now you also have a 2 on the outside because of here, it's not like 32 or 23. You just multiply them. Does that kind of make sense, Jack? So that's just the rule. If you have something else on the outside, you have to multiply it. Just like how if you had something else on the inside, you would have to multiply it. And maybe this will give us like an inside. So I think the more you practice, the easier it'll be. Okay, so I'm going to circle this 2. 6 is 3 times 2. I'm going to circle the 3 and the 2. 9 is 3 times 3. I'm going to circle the 3s because they're all prime numbers. Okay, so remember, I'm only looking at the circled numbers. I only want to look at the prime numbers. And it looks like this has an imaginary 2 in there as well. That means I'm taking out groups of 2. So I take out a group of 2, put it on the outside. I can take out a group of 3s, put it on the outside. So remember, if you have more than one thing on the outside, you just multiply it. And then here you have a 3 left over without a friend, so that stays on the inside. So you have this thing, which is 6 radical 3, plus this thing, which is also 6 radical 3. So what does the whole thing equal? (12 radical 3). Right, because 6 plus 6 is 12. You can add your outside numbers, and then the radical 3s just stay the same. I know this is weird. This is very different. We're going to practice all day today. Okay, so again, how do I double check my answer? Well, type in your original problem in your calculator. I end up getting 20.78. Type in your final answer in your calculator. I get the same decimal, so I know that I did it right. Okay, so let's try again. I know this is weird. Okay, that's why we're practicing together. That's why we're spending a week doing this. So, second one. Let's do. Okay, 10 radical 12 plus radical 27. Okay, so again, can't combine these because there's different numbers in your radicals. So I can't just combine them right away. But what I can do is I can break them apart and simplify it. So 12 is 3 times 4. Circle the prime numbers. 4 is 2 times 2. Okay, does anyone in person think they know? 12 is what radical what? Yep.
No.
Someone else think they know? Cameron? Okay, it's 2 radical 3. So how did she get this? So I have groups of 2 right here, right? So if I have a group of 2, I cross out a pair of 2s because I have 2 of the same number. So that goes on the outside. And then I have a 3 on the inside left over with no one to combine with. So that's a 3 right there. But then remember, I had this 10 originally in my problem. So don't forget to transfer it down. So yes, this is 2 radical 3, but I had a 10 there. So technically it's 20 radical 3. Okay, let's do 27. So 27 is 3 and 9. Only circle your prime numbers. 9 is 3 and 3. And remember, I need groups of 2. So does anyone think they know for this one? This is what radical what? Casey? It's 3 radical 3. So why? I need groups of 2. So I have 2 3s here. So I write it one time. But then I still have a 3 here that doesn't have a friend. So that's why it's 3 radical 3. And then there was a plus in between. So 20 radical 3 plus 3 radical 3. What does that equal? 23 radical 3. Okay. I need your honest opinion. Do you want to practice more of these or can we move on? Okay, maybe let's practice one more. Because I think I heard someone say practice. So let's practice one more and then we'll move on, okay? Online kids, you are also being very, very quiet. So that worries me just a tiny bit. Let's do another one. All right. Let's say I have this. 2 radical 18 minus 2 radical 20 minus 2 radical 5. So it's not any more difficult. I'm just adding more to the problem. I'm just like making it longer. 2 radical 18 minus 2 radical 20 minus 2 radical 5. You're still doing the same exact process though. Okay, so 18, what times what? 6 times 3 or 9 times 2. Either one, you're going to get the same answer. 6 is 3 times 2. Okay, so somebody online, do you think you can tell us radical 18 is what radical what? Does anyone in person think they know then? This is what radical what? 3? Okay, so just the 18 part. So just the 18 part, not with like the 2 attached on the outside, but just the 18 part. Jack? 3 radical 2. So remember how we said you have groups of 2 here that you need. So I'm taking out a group of 2. So that's a 3. And then I have a radical 2 on the inside. But then don't forget you had the 2 here on the outside. That's why it's technically 6 radical 2 after you do the whole thing. But radical 18 is just 3 radical 2. So I have 6 radical 2. That's what this part equals. Okay, minus, so now let's do this part, 20. So 20 is 4 and 5, or 10 and 2, doesn't matter. 4 is 2 and 2. Okay, I'm going to ask the online kids again. Am I muted? I sure hope I'm not muted. No, I'm not muted. Okay, anyone online want to try this one now? Just the radical 20 is what radical what?
4 radical 5.
Close, so close. Not 4 radical 5 though.
2 radical 5.
2 radical 5. So again, I have a group of 2 here. So that means I'm taking out a group of 2. Oh, here's 2 numbers that are the same. So I cross out both, but just write it 1. So it's 2, and then there's a 5 left over this time. So radical 5. But don't forget that I had this right here, this original 2. That's why that becomes 4 radical 5. Okay. Now let's do this final one, minus 2 radical 5. Can I break down 5? No, so this is just minus 2 radical 5. So remember how I said things that can combine are the things that have the same radicals. So the radical 5 and the radical 5 are like terms, so I can combine those two, but I just can't combine that with anything. So final answer would be 6 radical 2, and then for this one, it would be -4 and -2 gives you -6 and then radical 5. So then that would be my answer. Okay. So your IXL today are EE2 and EE3. Let me quickly double check before I move on to something completely different. Let me see what EE2 and EE3 look like. So EE1 was just simplifying. You should have been able to do that yesterday. EE2 and EE3. EE2. So simplifying radical expression. So let's see what the problems look like. Come on. Okay, so that with letters. Okay, so you can do it with letters. And I'll try some again with you later. And then EE3. Oh, darn it. That's not E. EE3. Ah, fractions. That's what we're doing today. Okay, so let's do that then. All right. Now let's do it with fractions. So if you need more paper, go grab more paper. If you want to use the back, please use the back. If you want to use the side, if you have room, please use the side, whatever you need. Okay, So now this time, let's go ahead and do it when I have fractions. So let's say I have the square root of 23 over 9. So do you see how I have a fraction with the square root? So guys, when I do this, first thing I want to do is I want to say, okay, so this technically means what's the square root of 23 over what's the square root of 9? It's kind of like I'm distributing the square root to the top and the bottom. Okay, well, square root of 9, what does that just equal? 3, right? Do you see how I just can write 3? Because I already know the square root of 9 is 3. But why? Because 9 is 3 times 3. I want groups of 2. So if I crossed out both and I write 1, it's just 3, right? But I know the square root of 9 is just 3. 23, can I break down 23? No. So it's just the same. So do you see how that is my answer? So whenever I have a fraction, I have to distribute the square root to the top and the bottom. And then you just try to simplify the top and then try to simplify the bottom and then be done with it that way. Okay. Now let's try something slightly more difficult. What if I had this then? Square root of 8 over 4. So this is what I always want you to do first. 8/4, those are both even numbers. I can simplify 8/4, can't I? So can't I just go alpha y equals enter? 8/4 as a fraction. That is just 2. So do you see how this is just equal like to the square root of 2? Does that make sense? Because 8/4 could have been simplified. So I just get the square root of 2. And then I can't like break down 2. So that's the answer. But let me show you another way. Okay, so if I said this, some of you might want to think of it like this. Okay, that's the square root of 8 over the square root of 4. Well, the square root of 4, I just know the square root of 4 is 2, right? That's just like, I've known that since 6th grade. 8 though, so 8, remember how I said is always 2 times 2 times 2? So that's 2 radical 2, right? Because I need groups of 2. So take out a group of 2s, and then I have a 2 left over on the inside. But look at your whole numbers. 2 over 2 can cancel out. That's just 1. So that just gives me the same answer, radical 2. I feel like that way is a lot longer how to solve it than this way, but either way gives you the same answer. Okay, so let's do this one then. Something kind of similar. So square root of 4x squared over 64. So remember, if I have a square root of a huge fraction, I'm going to take the square root of the top over the square root of the bottom. Well, what's the square root of 64? 8. That's just a whole number. What's the square root of 4? 2. Ooh, okay, do you remember this from yesterday? What's the square root of x squared? Just x, right? Because if I have x squared, I have 2 of them. So take out groups of 2, write it on the outside, there's nothing left. Okay, 2x over 8. But wait, that can simplify to be 1/4, right? So technically it's 1x over 4. You really don't even need the 1 there, so it's just x over 4. Or you can write 1x over 4. Reed, did you have a question?
No, it's not asking if you need the 1.
Okay. No, you don't need the 1. You could write the 1 if you want to, but you don't need the 1. Okay. Yes?
If you put the 1 on the I, so will it count wrong?
That's a great question. I have no idea if you put the 1 on the iExcel, will they count it wrong? I would say just don't do it because technically you really don't need the 1 there. But Jack, I'm sorry, I don't have a good answer for you. I would just say don't put the 1 there if there's a 1 there. All right, next one. Let's make it even more complicated. Okay, square root of 12 over 7. This time, none of these equal whole numbers, so I'm making it more difficult. All right, so remember how we said that's the same thing as square rooting the top and then square rooting the bottom. So here's the issue. Can 7 be broken down? No, right? And so I know it can't be broken down. So when it couldn't be broken down, we just like left it as it was, right? 23 couldn't be broken down, so I just left it as 23. So here's the big new thing. This is like the biggest rule in simplifying. I cannot leave a square root on the bottom. It is not okay. It's not simplified if there's still a square root on the bottom. So what I have to do is make sure that I get the square root out. So the only way I can get the square root out is by multiplying the top and the bottom by whatever you saw on the bottom. So there was a square root 7 on the bottom. So now you're going to multiply the entire problem by square root 7 over square root 7. Because again, I cannot have a square root left on the bottom. It's not okay. It wouldn't be simplified. So then on top, 12 times 7 is 84, right? So it's a square root of 84 on top. And then on the bottom, square root of 7 times the square root of 7. Does anyone think they know what that is? Just 7. It's just whatever that number is. If you multiply two square roots by the same thing, it's just that number. So like if I had the square root of 7 times the square root of 7, it just equals 7. If I had the square root of 12 times the square root of 12, it's just 12. If I have the square root of 54 times the square root of 54, oh, well, that's not 54. There. Square root of 54 times the square root of 54, it's just 54. Okay, square root of x times the square root of x is just x. It's literally just that thing without the symbol. Okay, so now, do you think I'm done? No. All right, what do I have to do now? Simplify which number? 84, right? 84 is even. Definitely 2 goes in there. So I would say 2 and 42. And then 42 is 21 and 2. Oh my gosh. Okay. 21 is 7 and 3. Okay, so I have a 2, 7, 3, and 2. So then what number can I pull on the outside? A 2, right? I have a group of 2. So that gets pulled on the outside. What's left over on the inside? 7 and 3, which make 21, and then all over 7. And then before you box it in, can you simplify 2 sevenths as a fraction? No. So then that's my answer. So I know, such a tiny little problem, and then boom, 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 it turns into that. It's so long and complicated, but I promise you, there is no other easy way. Okay, so let's do another one. Okay, number 8. So square root of 24 over 15. So square root of 24 over 15. So that's the same thing as saying the square root of 24 over the square root of 15, right? I'm just distributing the square root to the top and the bottom. All right, square root of 15 is not a nice whole number. Like it doesn't equal 2 or 3 or 4. So remember, I can't leave a square root at the bottom. That's not okay. So I need to simplify this by multiplying top and bottom by square root 15, square root 15, right? Because I can't leave a square root at the bottom, the rule is to simplify it, multiply top and bottom by square root 15, or whatever was on the bottom. So 24 times 15 is a huge number, 360. So I get square root of 360 on top. And what's the square root of 15 times the square root of 15? Just 15. Okay. So 360. I know it's like 10 and 36. I know it's 2 and blah, blah, blah. But to save you some time, isn't it also just 24 and 15? Like, I know it's 24 and 15 because didn't we just multiply 24 and 15 to get 360? So if I have to simplify it, I might as well just use these two factors to get there. Okay, 24 is 6 times 4. So just break it down to as small as it will go. 6 is 3 times 2. 4 is 2 times 2. 15 is 5 times 3. All right, So 360 is 5 times 3 times 2 times 2 times 2 times 3. And I want to take out groups of 2. Cameron, question, answer? What? No, okay. Does anyone think? Cameron? 6 radical 10 over 15. Okay, you did that really fast. I don't even know. So let's take out groups of 2. So I have a group of 2 there. So right on the outside. I have a group of 3s. So put it on the outside. Remember, you always multiply them. And then radical, there's a 5 and a 2 left over. So that's how she got radical 10 over and then 15. Yes. So you were right. Congratulations. Seriously, good job. 6 radical 10 over 15. Before you stop, I would say see if 6/15 can be simplified. The easiest thing to do is just type it in your calculator. 6 over 15, 2/5. Oh, so it can be simplified. It's 2/5. So technically it's 2 radical 10 over 5. Okay, so 6/15 can be simplified to 2/5, so make sure you simplify it. The 10 does not simplify with the 15 because one's a radical and one's a whole number. Okay, it's just the whole numbers get simplified with the whole numbers, the radicals get simplified with the radicals. Okay, let's try another one. Let's see, I'm going to try to give you a different one. Oh, okay. Okay, square root of 49x to the third over 98. Square root of 49x to the third over 98. Okay, so the square root distributes to the top and it distributes to the bottom. Is 98 a perfect square? No. Like it doesn't equal 9, it doesn't equal 10, it doesn't equal 7. So I have to multiply top and bottom by what? Yeah, square root 98. Square root 98, right? Because I can't leave this at the bottom. I can't have a square root at the bottom. Okay. So 98 times 49 is a huge number, but that's okay because we already know the factors of it because we're multiplying them together. So it's, yeah, 4,802 x to the third, right? Because you still have that x to the third over, and then what's square root 98 times square root 98? 98. Just 98 whole. Okay, so 4,802. Do yourself the favor and don't try to divide by 2 or divide by 3 or whatever. Because you know 4,802 is just what times what? 49 times 98. Just these two numbers, right? Because we had multiplied them together to get this. So 49 times 98. Okay, so 49 is easy. 49 is what times what? Yeah, 7 and 7. And we can circle those because those are prime numbers. 98 is the big one, I think, that we have to break down. So 98, what goes into 98?
49 and 2.
Really?
Yeah.
49 and 2. Okay. Oh, well then there you go. 49 and 2. Not so bad because 49, another one is a 7 and a 7. So if I'm just doing the number part, 4,802 is what radical what? What did you say? Not 14 radical 2. Close. 49 radical 2, right? Because you have a 7 and a 7, so you write it once, and then you have another 7 and a 7, then you write it again, and then you have the radical 2. So that's how I get 49 radical 2. But then hold on, you have this x to the third you also have to break down. So remember how we said if you have 3 x's, You're still looking for groups of 2. So you have 2 and you write it down once. And then you have 1 left over here on the inside. And then you have 98. So that's how we had gotten 49x radical 2x all over 98. But before you do anything, see if the 49 and the 98 can be simplified. So 49 over 98 is just 1/2. So then I have 1x radical 2x over 2, because 49 over 98 is just 1/2. And then as Jack had asked in IXL, should I write the 1? Honestly, I don't know. Maybe you just write x radical 2x over 2. But if you had the 1 there, like mathematically, it means the same thing. Okay, how do we feel? Can I teach you something harder? Because I'm sorry, it doesn't even get, this is still like relatively, I know it's not easy, but compared to what we're going to be learning this week, this is relatively on the easier side. Let me just do one more thing to you, and then tomorrow I'll have to blow your mind a little bit more, okay? Because it'll be completely different. Okay, so let me do one more concept with you. Maybe we'll practice like 2 or 3 of these examples, and then we'll be done, because I know your brains are tired, okay? It's a lot to take in. All right, so this time, let's say I have 4 over the cube root of 6. So first of all, 2 things should pop into your head. Oh no, there's a root at the bottom. I can't have this as my answer with a root at the bottom. But then, do you also see how this is a cube root this time? This was a square root. This was a square root. This is a cube root, which does make a difference. Okay, so I think some of you are going to do this, which is wrong. But this is all you know. You would say, oh, multiply by the cube root of 6, multiply by the cube root of 6. Because I always said multiply with whatever's at the bottom. But that's if you had a square root, okay? If you have a cube root, so think to yourself, the reason why I multiplied by like 15 and 98 was because you see how like for 15, if I have a 15 here and I have a 15 here, that's my group of 2 to make 1 15 here. So like if I had square root of 98 times square root of 98, this is 98, this is 98, I have my group of 2 to make 98 here, right? Because I want this to be a whole number. So here, 6. 6 is 3 times 2, right? So that really can't be broken down. But you see how if I multiplied by a cube root of 6 again, I would have 1 6 here, I would have 1 6 here, but I need a group of 3 this time. So hear me out. Do you see how technically I need to multiply by a cube root of 36? Because here's a 6, and then these 2 are 6s. Now I have my group of 3 to be able to make this equal a whole number, right? I have my group of 3 6s to get my 6. The point is you want the group of that same number. So I need to multiply by the cube root of 36. I know that some of you are confused. We'll practice another one, but let's just get through the first one, okay? So that would be 4 cube root of 36. And then let's break down 36. So 36 is 6 times 6. 6 is 3 times 2. 6 is 3 times 2. So I had a 4 on the outside. Okay, this time I need groups of 3. Can I get any groups of 3 for this? No, right? I get groups of 2, but I don't want groups of 2. I want groups of 3. So this just stays cube root of 36 all over 6. Do you think I'm done? No, because what can I simplify? 4 6, right? The whole numbers. 4 over 6 simplifies to 2/3. So this is 2/3, and then I still have the cube root of 36. Okay, I know that was weird. I'm just going to do 2 more with you, and then I promise we're done for the day, okay? Okay. So what if I had this? 2 over the cube root of 9. So don't multiply top and bottom by cube root of 9 because this time you have a cube root. So think to yourself, okay, 9 is 3 times 3. So I already have 2 of them. How many more 3s do I need to make my group of 3? Just one more. So do you see how technically I'm only going to multiply by one more 3? Because now I have my group of 1, 2, 3 that I can cross out and write one time. So on the top, it's just 2 cube root of 3. And at the bottom, what is the cube root of 9 times the cube root of 3? 3, just 3, right? Because it was these 3s that I wanted, and that was my group of 3. So you cross out 3, you write it once, and that's your answer, because 2/3 can't simplify. Okay. So last one. Let's say I have 10 over the cube root of 25. Okay. So I know that I need a group of 3 and 25 is 5 times 5. Does anyone think they know what I need to multiply top and bottom by? Just the cube root of 5, right? If I multiply by a cube root of 5, then I have my 1, 2, 3, my group of 3 of the same number. So what is the cube root of 25 times the cube root of 5? Just 5, right? Because that was my goal, 1, 2, 3. So I just had 3 5s to get me a 5. And then on top, 10 cube root of 5. But remember, I can simplify, not 1/2, 2, right? Because 10 over 5 is just 2. So it's 2 cube root of 5 over 1, but you don't need the over 1, so it's just that. Okay. So we will practice this concept a little bit more tomorrow, and then I'm going to do something, the hardest thing that will probably blow your mind a little bit, okay? Tomorrow. All right, so thank you for being here. Thank you for hanging in with me.